Okay, let's start out in our state. In the state, we want to identify our hypothesis, and we also want to identify the parameter in context along with our significance level. Our null hypothesis is that the means are equal to each other. There is no difference in their opinions of looks. The alternative is that there is a difference. We represent a difference with not equal to here. You could also have your hypotheses as mu1 equals mu2 and mu1 not equal to mu2. And then we want to identify. Identifying mu1 to be the true population mean score for females at Los Medanos College and mu2 being the true population mean score for males at the college. Now we're going to test, they don't tell us what significance level, so we're going to test at an alpha equals 0.05 level of significance. That's our standard measurement. In the plan portion, we want to go ahead and check our conditions. In terms of random was not stated in the problem, but we need to assume that the samples are randomly selected. For normal, we need to check both sample sizes. Either they need to come from normal populations or their sample sizes need to be large enough. Our female population was 150 and our male population was 85. Above, we are given that the sample size for the first sample is 150. We have the sample mean, 10.733334, and the sample standard deviation is equal to 4.254751. Sample size 2 is 85. Mean is 13.3294115. Standard deviation of the sample 2 is 4.0189676. A t-value of negative 4.657 with the degrees of freedom equal to 183.97 and a p-value of less than 0.0001. All right, in our conclusion, remember we talk about our p-value, we compare it to our level of significance, we mention our null and also our alternative in context. Since our p-value is less than 0.0001, it's less than our alpha equals 0.05 level of significance, we reject the null. There is evidence to support the claim that there is a difference in opinion between females and males. We are asked to also construct a confidence interval, and if we were to have a question like this on an exam in a confidence interval, you want to do the 4-step process for a confidence interval as well. The only difference is in your do, you get the interval rather than the test statistic. Adding our confidence interval up here in pink, what we have here is a negative value. We have negative 3.696 to negative 1.496. So the difference is that females and males have a difference that is not 0. This backs up what we have from our test statistics. Since 0 is not in our interval, there is a difference. And so our p-value tells us, yes, our claim is there's a difference, and our confidence interval also backs that up. For number 4, I would like you guys to go ahead and calculate the hypothesis test and construct a confidence interval on your own, and then come back and compare your results. Here we are with our finished conclusion. In the state, this problem was asking about whether undergrad students sleep less than graduate students, which we will write as mu1 minus mu2 equals 0, and then less than for our alternative hypothesis. You see the both ways that I've written it here. And mu1 is the true population mean number of hours undergrad students sleep, and mu2 is the true population mean number of hours grad students sleep. In the plan, this problem does state that the samples are randomly selected. For our normal conditions, 75 is greater than or equal to 30 and 50 is greater than or equal to 30, so we can go ahead and use normal calculations. And I have noticed that OLI has started talking about independence as a condition, which is great. And we do want to talk about independence for our samples where each individual value is independent of each other. Like a grad student's sleeping habits doesn't influence another grad student's sleeping habits. In the do, they actually asked us to go ahead and load data into StatCrunch by downloading the file first. I will show you that at the end of these videos. The t that we get is negative 1.23, which is not outside of 2 standard deviations. This means that our p-value is not small. It's about 11%. So we're going to conclude that our p-value of 0.1106 is greater than our alpha equals 0.05 level of significance, which means we fail to reject the null because there is not evidence to support the claim that undergrads sleep less than graduate students. In pink, we have our confidence interval, and if you notice, the interval goes from negative to positive, which means that 0 is in the interval, meaning that the difference is 0. There is no difference between grad students and undergrad students sleeping. This confidence interval backs up what our test statistic had. So we're confident, this is a 95% confidence interval. We're 95% confident that the interval from negative 0.61 to 0.14 captures the true average difference between undergraduate and graduate students' sleeping habits. Notice that in the previous problem, when we did have a p-value where we rejected, the interval showed all negative values. If it shows all negative values or all positive values and 0 is not in the interval, then that means we do have evidence that there's a difference. But this interval contained 0, which means that there isn't evidence of a difference.